Welcome back everyone. In the previous video, we discussed different age relationships including the multiples of ages and average ages. We also solved some examples based on these relationships. In today's video, we will continue our discussion on problems on ages. We will learn about some more important age relationships and solve examples based on them. So let us begin with the next concept, consecutive age relationships. Let us move on to another type of relationship called consecutive age relationships. Consecutive ages. The word consecutive means following one another in order. For example, 20, 21 and 22 are consecutive ages because each age is exactly 1 year more than the previous age. If we don't know the ages, we can represent the three consecutive ages as x, x plus 1 and x plus 2. For example, if the ages of three people are consecutive and the youngest person is x years old, then the next person's age is x plus 1 and the third person's age is x plus 2. This representation helps us convert the information given in an age problem into a mathematical equation. Now, let us consider an example involving consecutive ages. The example says that the ages of three brothers are consecutive integers and their sum is 39 years. We have to find their ages. First, let us understand what consecutive integers means. They are numbers that follow one another with a difference of exactly 1. For example, 10, 11 and 12 are consecutive integers. Since the three brothers have consecutive ages, we can represent their ages as x, x plus 1 and x plus 2. Here, x represents the age of the youngest brother. The next brother is 1 year older, so his age is x plus 1. And the third brother is another year older, so his age is x plus 2. We are given that the sum of their ages is 39 years. Therefore, we can form the equation x plus 1 plus x plus 2 which is equals to 39. Now combine the terms. We get 3x plus 3 which is equals to 39. Now subtract 3 from both sides. We get 3x which is equals to 36. Now divide both sides by 3. We get which is x which is equals to 12. So the youngest brother is 12 years old. The other two ages are 12 plus 1 which is equals to 13 years and 12 plus 2 which is equals to 14 years. Let us verify the answer. The sum of their ages is 12 plus 13 plus 14 which is equals to 39 years. Also, the ages are consecutive because each age differs from the next by 1 year. Thus, the conditions are satisfied. Now, let us consider another example involving consecutive ages. This time, the ages are consecutive even numbers. The example says that the ages of four sisters are consecutive even numbers and their total age is 68 years. We have to find their ages. First, let us understand what consecutive even numbers means. They are even numbers that follow one another with a difference of 2. For example, 10, 12, 14, and 16 are consecutive even numbers. So, if the youngest sister's age is x years, the ages of the four sisters can be represented as x, x plus 2, x plus 4 and x plus 6. We are given that their total age is 68 years. Therefore, we form the equation x plus 2 plus x plus 4 plus x plus 6 which is equals to 68. Now combine the terms. We get 4x plus 12 which is equals to 68. Subtract 12 from both sides. We get 4x which is equals to 56. Divide by 4 on both sides. We get x which is equals to 14. So the youngest sister is 14 years old. The other three ages are 14 plus 2 which is 16 years, 14 plus 4 which is 18 years and 14 plus 6 which is 20 years. Therefore, the ages of the four sisters are 14, 16, 18 and 20 years. Let us verify the answer. The sum of their ages given in the problem is 68 years. Let us check this. We have 14 plus 16 plus 18 plus 20 which is equals to 68 years. Thus, we got the sum of their ages 68 years. Also, each age differs from the next by 2 years. So, they are consecutive even numbers. Thus, the conditions are satisfied. Now, let us consider an example where more than one age relationship is given. The example says that the sum of the ages of a father and his two sons is 72 years. The elder son is 4 years older than the younger son, and the father is twice the age of the elder son. We have to find their present ages. Here we have three pieces of information: the sum of their ages, the difference between the son's age, and a multiple relationship between the father and the elder son. Let us use the younger son's age as our starting point. Let the younger son's present age be x years. The elder son is 4 years older than the younger son. Therefore, elder son's age will be x plus 4 years. Now, the father is twice the age of the elder son. Therefore, father's age will be 2 times the quantity x plus 4 years. We are also given that the sum of all three ages is 72 years. So, we add their ages and form the equation. We get x plus 4 plus 2 times the quantity x plus 4 which is equals to 72. Now let us simplify this equation. We get 4x plus 12 which is equals to 72. Subtracting 12 from both sides, we get 4x which is equals to 60. Now, dividing on both sides with 4, we get x which is equals to 50. Since x represents the younger son's age, the younger son is 15 years old. The elder son's age is 15 plus 4 which is 19 years. Father's age is twice the elder son's age. Therefore, we get father's present age 2 into 19 which is equals to 38 years. Therefore, the present ages are younger son is 15 years, elder son is 19 years and father's age is 38 years. Let us verify the answer. Their total age is 15 plus 19 plus 38 which is equals to 72 years. The elder son is 4 years older than the younger son and the father is twice the elder son's age. Therefore, all the given conditions are satisfied. Now, let us look at a key strategy that can help us solve different types of age problems systematically. Whenever you come across an age problem, do not try to solve it immediately. Instead, follow these steps one by one. Step 1. Read the question carefully. First, understand exactly what information is given. Pay attention to words such as present, years ago, after, some, difference, ratio, twice, three times, and so on. Step 2. Assume the unknown age as a variable. If an age is not given, we can represent it by a variable, usually x. For example, if the daughter's age is unknown, we can say daughter's age is x years. Step 3. Express the other ages using the same variable. Use the relationships given in the question to express the other ages. For example, if the mother is 20 years older than the daughter, then mother's age will be x plus 20. If someone is twice the age of another person, we can write the age as 2 times x. Now step 4. Use the given relationship to form an equation. Now, use the information given in the problem such as the sum, difference, ratio, multiple, past age or future age to form an mathematical equation. For example, if the sum of two ages is 50, we can write x plus 20 will be equals to 50. Step 5. Solve the equation. Solve the equation to find the value of x. Then substitute the value of x to find the actual ages. Finally, it is always a good idea to verify your answer by checking whether it satisfies all the conditions given in the question. So, remember the basic strategy: read, assume, express, form an equation, solve, and verify. If you follow these steps carefully, you can solve many different types of age problems systematically and confidently. Note that we have learned about different types of age relationships and solved several examples. It is time to apply what we have learned. In this slide, we have some practice questions on problems on ages. I would like you all to try each question on your own before checking the solution. As you solve these questions, remember the important steps. First, identify the information given. Second, identify the relationship between the ages. Third, represent the unknown age using a variable when necessary. Fourth, form an equation using the given conditions. Finally, solve the equation and verify your answer. Take some time to solve all 5 questions independently. Try not to look for the solution immediately. The purpose of these practice questions is to check how well you can apply the concepts we have learned. Now, let us look at the real-life applications of age problems. You may wonder why we are learning these types of problems and where they are useful. Age-related problems are commonly included in competitive exams where questions test our ability to understand relationships and solve problems logically. They are also frequently asked in campus placement aptitude tests. Solving age problems helps students develop the ability to translate information given in words into mathematical equations. Similarly, age problems can appear in banking and government recruitment examinations, particularly in the quantitative aptitude and reasoning sections. They are also useful in logical reasoning assessments because we need to identify relationships, analyze the given conditions, and arrive at the correct answer. Apart from examinations, the same type of thinking can be useful in everyday situations involving age comparisons and planning. For example, we may compare the ages of family members, calculate ages at a particular time in the future or past, or determine age differences. So, learning age problems helps us develop not only mathematical skills but also logical thinking, problem solving ability, and the ability to interpret information carefully. Therefore, the concepts we have learned in this section can be useful both in competitive examinations and in practical situations. Before we conclude this section, let us quickly review what we have learned about problems on ages. First, we learned the basic concept of age problems and how to identify the information given in the question. Next, we learned about present, past, and future ages and understood when to add or subtract the given number of years. We then studied different age relationships such as sum and difference of ages, ratio of ages, multiples of ages, average age, and consecutive ages. We also learned how to convert the given information into mathematical expressions and equations and use them to find unknown ages. Through the examples and practice questions, we learned how to solve problems involving two or more age relationships. Finally, we discussed the real life applications of age problems, particularly their importance in competitive exams, aptitude tests, and logical reasoning. So, the key idea to remember is read the question carefully, identify the age relationship, represent the unknown age appropriately, form the equation, solve it, and finally verify the answer. I hope this section has helped you understand the basic concepts and methods used to solve problems on ages. Thank you for listening, students.